Hello, everyone, and welcome back to your channel, Math Made Easy. In today's session, as I mentioned before, we are going to use uh, a method called Cramer's rule in solving a system of linear equations. And this method depends on using determinants only. Okay, so we're not going to use any matrices. Remember how we used the cofactor method to find the determinant of a matrix? We did it twice. We did it once specifically, and then last time when we were discussing about the cofactor and the adjoint to find the inverse, we also used it to find the determinant. So that is basically what we are going to do today. Cramer's rule. Uh, so let me write three equations, linear equations, and try to solve those. So we are going to say 3x plus 2y plus z equals 8. So do mass x minus 2y minus 3z equals 4. And finally, 2x plus y plus z equals 7. Okay, so let's assume we have these three equations and we want to solve for x, y, and z. So let's first write the matrix A, which is 3, 1, 2, 2, negative 2, 1, 1, negative 3, 1. I was going to write z, okay? And we see how we find the determinant of that matrix. If the determinant, like we said before, is not 0, we can proceed. If it's 0, we stop and we say, oh, there is no unique solution, or maybe there is no solution at all for that system, okay? So, as I did last time, I'm gonna do it again for if you have any trouble finding the cofactor directly. We are going to do the matrix of minors. So for the 3, I'm going to hide and say negative 2 minus negative 3 is negative 2 plus 3. It's 1. And then here for the 2, I say 1 minus negative 6 is 7. And here we do 1 minus negative 4 is 5. Here we get 2 minus 1 is 1. For the middle number, you get 3 minus 2, it's also 1. For the negative 3, I do 3 minus 4 is negative 1. For the bottom row, you get negative 6 plus 2 is negative 4. For the middle number, you get negative 9 minus 1 is negative 10. And for the last one, you get negative 6 minus 2 is negative 8. From here, we say that for these guys, the diamond shape, we are going to change its signs. So to get the cofactor, we say 1 stays, 7 changes, 5 stays, 1 changes, 1 stays, negative 1 changes, negative 4 stays, negative 10 changes, and negative 8 stays. So that's the matrix of cofactors. Okay? Remember we said we can multiply any row or column by the corresponding row or column, and we should get the same result. Let's see if we did these correctly. You have 1, I have 7, we have 5, 2 minus 1 is 1, 3 minus 2 is 1, 3 minus 4 is negative 1, just to be on the safe side, because last time Oh, it didn't work. Or 2 sessions ago. Okay, I think this is correct. We change those. Okay, so let's find the determinant. We will always do that, okay? Because if it's 0, we stop and we say the system doesn't have a solution. Let's pick two things. Let's pick, for example, the first row and then maybe the second column or something. So first row, 3 times 1 plus 2 times -7 plus 1 times 5. So I get 3 minus 14 plus 5. 3 plus 5 is 8, minus 14 is -6. Let's say second column. We can do all of them, but just to save time. 2 times -7 minus 2 times 1 plus 1 times 10. -14 minus 2 plus 10. So it's -16 plus 10 is -6. So we know it's -6. Here is the very good thing. And that's why I use this method, by the way, to find the determinant. You will know in a second. To find the value of x, we are going to divide a matrix that we call matrix A1. Has nothing to do with the stakes also, please bear me that. Oh, determinant of A1 over the determinant of A. And y would be the determinant of A2 over the determinant of A, and z will be the determinant of A3 over the determinant of A. So what is, we already found the determinant of A, which is -6. But what is A1, A2, A3? A1, A2, A3 is here we let the right-hand side replace the first column. So it's the same matrix, but instead of 3, 1, 2, I will have 8, 4, 7. For A2, I'm going to let the right-hand side replace the second column, and for A3, we let it replace the third column. You don't need to do any of that. You know why? Because all what you have to do to solve for x is to expand the first column. Expand first column after replacing the first column by that. So it's as if you are taking these numbers and multiply them by the first column to get A1, by the second column to get A2, and by the third column to get A3. So no more work. So x becomes over -6 equals. I'm going to multiply 8 times 1 plus 4 times -1 plus 7 times -4. So -28 minus 30, -28 plus 8 is -20, minus 4 is -24. Divide by -6, x is 4. See how easy it is. Y equals. Now I'm going to multiply this by the second column because I'm going to replace that by the second column. So expand the second, expanding second column, of course, after replacing it by the right-hand side. I didn't want to rewrite matrix A1. You could say 8, 4, 7, 2, -2, 1, 1, -3, 1. And then for A2, it would be 3, 1, 2, 8, 4, 7, 1, -3, 1. And then for A3, you would say 3, 1, 2, 2, -2, 1, 8, 4, 7. And then you expand. So when we expand the second row, you get -56 plus 4, that's -52, plus 70. 70 minus 52 is 18, and 18 over -6 is -3. Finally, the z becomes expanding the third column. 8 times 5 is 40. 4 times 1 is 4, so 44. Minus 56. 44 minus 56 is -12, and -12 over -6 is +2, and the problem is solved. I think it works perfect. All what you have to do is to find the cofactor, and many of you by now, they can go from here to there in one step. Find the determinant. If it's not zero, multiply the first column by the first column of the cofactor and divide by the determinant of A to get X, multiply by the second to get Y, by the third to get Z. Okay? I hope this was short and easy, and I hope you learned it and enjoyed it. Thank you very much for your time, and I hope to see you soon. Have a nice day.